Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today, let us discuss about storage classes in C language. Now, what for storage classes are used and what is the uses of storage class, what information it tells. So, storage classes are used to describe the features of a variable or function. Now, these features are basically what is the scope of the variable, what is the visibility of the variable, what is the lifetime of the variable, and so on. So, these variables like this information, scope and lifetime or visibility of a variable will help you to trace the existence of a particular variable during the running of the program. Now, based on this, scope is nothing but where a variable is available for use, and lifetime is where up to what time the variable persists. Whether the lifetime of the variable is within the function itself or lifetime of the variable is throughout the program, that is called the lifetime or visibility of the variable. Now, based on this concept, the storage classes are of four types. One is called automatic storage class, registered storage class, static storage class, and extern storage class. Now, let us discuss in detail about each of the storage class. So, let us start with your automatic storage class. So, you can have a look at the picture. So, storage classes in C language are divided into four types. One is called the automatic storage class, registered storage class, static storage class, and external storage class. So, let us start with automatic storage class. Now, if you will see the storage class, the overall concept of storage class, now four things or four important points are there in every storage class concept. One is called where the variable is stored, that is called the storage. Then what is the initial value if a variable is declared of different storage classes, and what is the scope of the variable, and what is the lifetime of the variable. Now, in brief, in this slide, let us discuss about the automatic storage class first. So, in the automatic storage class, if a variable is declared of type automatic storage class, then the storage is in stack memory, and the initial value is garbage, and scope is within the block in which it is defined, and the lifetime is till the end of the block. So, normally the automatic storage classes are local variables. So, it is stored in stack memory, and the default initial value is garbage, and the scope and lifetime is within the block in which it is defined. Then the second type of storage class is called external storage class. Now, the external storage class, the variables are stored in data segment. So, this is the storage. The default initial value is 0, and the scope is global across multiple files. If a variable or a function is declared to be external, then its scope and lifetime is across the files, or global in multiple files you can use until the end of the program, that the external storage class lifetime will be there. Then the third type of storage class is called static storage class. In static storage class, again the variable is defined in the data segment. Your initial value, the default initial value is 0, and the scope is within the block in which it is defined, and the lifetime is till the end of the program. And the last type of storage class is register. So, instead of storing the variables in memory, it will be storing the variables in CPU registers. So, the storage is in CPU register. Default initial value is garbage, that is unknown, and scope is within the block in which it is defined, and the lifetime is till the end of the block. So, this is overally regarding the four storage types or storage classes which is defined in C language. Now, let us come to understand the automatic storage class first. So, a variable declared inside a function without any storage class specification is by default considered as automatic storage class. And if they are created when a function is called and are destroyed automatically when the function's execution is completed. That means when you do not mention the storage class of any variable, that is by default rated to be automatic. And the keyword which is used for defining the automatic storage class is auto. The key auto is used for defining the storage class to be automatic. Now, these automatic variables are normally the local variables because they are local to a function, or the automatic variables are the scope of the function, the variables are within the function only. So, by default, they are assigned the garbage value by the compiler. As soon as these automatic variables or local variables are declared, by default, they will be containing the garbage values by the compiler. Now, coming to the three important parameters or points here. First of all, what is the scope, what is the default initial value, and what is the lifetime if you are using automatic storage class. So, coming to scope, the variables which are defined as automatic storage class are local to the function in which it is defined. So, the scope is limited to or within the function itself. Then, default initial value is any random value which we call it as the garbage value. And the lifetime is till that function exists or the method or block in which the variable is defined. So its scope or the lifetime is limited to the function itself. Now, to specify the storage class of a variable that it is automatic storage class, what is the default syntax that you have to use? So whenever you declare a variable, we normally write int I or we write float j. This is the way we declare the variable. So this integer is nothing but this is int or float is nothing but these are known as the data type, and ij are known as the name of the variable or variable name. So whenever you have to write the storage class information, so you have to simply write auto int I. So whenever we write like this auto is nothing but it is called the automatic storage class for the variable, and the second one is called the data type, that is integer type it is, and third one is known as the variable name. So this is the way it is defined. So the general syntax is storage class followed by variable name, then variable data type followed by variable name. So this storage class information, if you do not mention anything, then by default it is treated to be automatic only, and it tells about the scope, lifetime, and the default initial value of the variable. So the scope is nothing but it is local to the function, and lifetime is within the function itself, we can use it, and the default initial value for I will be garbage. So this is about automatic storage class. Now let us understand one example that how to use automatic storage class. So first of all, let us go for the syntax or declaration. So the syntax is automatic int, name of the variable is age. So here inside a main function, we can declare the normal way of declaring local variables is int detail. Detail is a local variable. Okay. So the local variables are by default automatic in nature. So we can also write automatic int details. So both are same. So whether you write or do not write, by default it is taking as automatic storage class. Now let us come to this example. So here there are three variables that are which is declared with the same name with different values. So here automatic int j is equal to 1 initially. Now if you will see the brackets, then this is the scope and lifetime of variable j is equal to 1. Second time again j is declared with initial value 2. So automatic int j is equal to 2. Now in this case the scope and lifetime is within this boundary only. So and the third time when automatic int j is equal to 3 is declared, then its lifetime is within this block only. Now here the variable is declared 3 times with the different scope and lifetime within a function or within a block itself. Now whenever you will print the value of j, in what order the values are getting printed, let us understand. So first time in the innermost block, whenever you are printing the value of j, then the local variables are always getting high priority. So the local variable, the value of j is equal to 3. So here j is equal to 3 will be printed. Now its scope and lifetime is over. Now when you come out of this boundary, then you will find that j is equal to 2. That is having the scope. So here j is equal to 2 will be printed. So when you will come out of that, then j is equal to 1. So j is equal to 1 will come. So the scope and lifetime of the variable or visibility of the variable is in this manner. Then the second kind of storage class is known as the register storage class, and the keyword which is used is called register. Now the register variables inform the compiler to store the variables in CPU registers instead of memory. So registers are having faster accessibility than your normal variables, register variables, because the CPU registers are fastest compared to your main memory. Main memory is normally slower in nature than the CPU registers. So any variable that you kept inside the CPU registers can be accessed faster, but the size of the CPU registers are limited. The number of CPU registers are also limited. That's why the important variables or the variables which you will use frequently should be used in or should be stored in CPU registers. So normally only a few variables are stored in CPU registers. So one application of register storage class is using loops. For example, if you are using a loop, then that loop is running continuously for a particular number of times or for a fixed number of times. Then the looping variable will be accessed again and again frequently. So it is always better that you should store the looping variable in a CPU register instead of memory, so that fetching the variable and will take or the memory access time for the variable can be reduced. So the example is loops where the variable gets used number of times in the program in a very short span of time. So coming to the scope, lifetime and default initial value of register storage class. So first of all, the scope is local to the function in which it is declared. And the default initial value is nothing but it is garbage again. That is, you do not know what will be the initial value. So you just consider it is some undefined unknown value, that is garbage value. And what is the lifetime? Lifetime is within the function or block itself. So its scope is limited to the function itself. And how to declare one variable to be a register storage class? So you have to use the keyword register, then followed by data type, followed by name of the variable. So here this is the storage class name, register, then the data type, then followed by the name of the variable. But there is a important point over here to be noted, that whenever a variable is declared to be register, but in the CPU registers, if sufficient space is not available to store that variable as register, then by default, automatically by the compiler, it is treated to be automatic storage class type. So it is very difficult or there is no mechanism to understand or to find it out whether the variable is really stored in CPU register or it is stored in memory. So it is just a convention that we are asking for CPU register to store our variable into CPU register. But if the space is available, then the OS will decide whether the variable will go to the CPU register or not. If space is not available, then automatically that is treated to be automatic storage class type. Okay. So, but for a programmer, there is no way to identify whether it is really in CPU register or in main memory. Now, you can see one example here. Suppose you have declared registered int weight. Weight is variable. So, we have declared that it should be stored into a CPU register. Now, we are writing that we are declaring a pointer and we want to find out what is the address of this weight variable that we want to store into a pointer. Suppose PTR is a pointer and weight is the variable whose address need to be stored into this pointer variable. So if you want to do this kind of problem, then the address of register variable is normally requested. Till that time you do not know what is the address. So if it is instead of register, if it is automatic, then no problem. Memory will be assigned to that. Memory address will be there for that variable weight. We can get the address easily. But whenever it is register type, then the register type address is requested. So only certain types of variables are only placed into registers, and register variables are not given any initial value by the compiler. That's why we are treating that as to be garbage. Now, the third type of storage class is called static storage class. Now, in static storage classes, there are two types of variables you can use. One is called local variable, one is called global variable. So you can say static local variables and static global variables you can use. Now, static local variables are just like normal local variables only, that retain and store its value between the function calls or blocks. This statement is very important. Whenever a variable is declared to be a static local variable, then that variable will retain its previous value during the function calls. Okay, but a normal local variable, normally whenever the scope of the function is over or when you reach to the end of the function, then its value is not again reinitialized to 0. Okay, or the default value. But in case of static variables, it retains the value during function calls or blocks, and it remains visible only to the function or block in which it is defined. Okay, but whenever the variable is static global variable, then these are just like global variables. These are visible to the file in which it is defined. And for example, if you are writing static int count is equal to 10, if you write this statement, you are within a function or within a block, then the value of count is equal to 0 or any operation you do on count variable will be visible during function calls. Multiple times you call the function, you will find it out what was the last updated value for count. Okay, but for a normal local variable, every time count will be reinitialized to 0 itself. Okay, that is the difference between an automatic variable and a static variable. So static variable has a default initial value of 0 and it is initialized only once in the lifetime. But after that, it retains the value during function calls. That is the difference between automatic variable and static variable. Now, let us understand through one program. For example, initially we have declared one global variable which is a static type. So, static integer counter is equal to 7. That means the value of counter is equal to 7 will be visible throughout the program. When any updation is going on to the counter variable, then that updated value will be retained throughout the program. Let us see how. Now, we are checking inside the loop. The counter value is less than 10. That means 8 is less than 10. Yes. So, 7 is less than 10. Yes. So, if it is less than 10, then call one function called display function. So, the control will come to the display function and it will execute here. Now, here static int I is equal to 13. So, this is called a local static variable which is declared inside the function. Now, counter is equal to 7 is a global static variable. Now, what we are doing? We are doing increment. So I plus plus, so I becomes 14. Then we are printing the value of I and counter. So what is the value of I? I is a local static variable. So now it becomes 14 and counter is 7. Because it is a global variable, we have declared counter to, we have taken counter to be 7. Now, what will happen? Again, after executing this, the control will go to the program and it is doing counter plus plus. So now counter becomes 8 and after that return 0. So what will happen? Then the value of counter is 8 and again it will go to the loop and it will check the counter value is less than 10. That means 8 is less than 10 second time. Yes, it is true. Again call the display method. So the control will come to display method and it will see, you will see that again I will not be initialized with 13. I will retain the previous incremented value which is nothing but the value of I is 14 last time. So it will retain that value. Reinitialization will not take place. So again I value is incremented I plus plus. So I value becomes 15. So next time it will print 15 and counter value is equal to 8. Again go back to the main function. Counter is incremented to now 9. So again call the function. 9 is less than 10. Yes, true. Again call display method. So control will come to display method. And you can see that the last time the incremented value for I was 14. It was 15. So it will retain that value. So it will not be reinitialized with 13. So the I value will be taken as 15 only. And then I is incremented to 16. And then we are printing the value of I and counter. So the value of I is 16 and counter value is equal to 9. So next time when it will do counter plus plus, the counter becomes 10 and 10 is less than 10, which is false. So now the program will stop. So this way, the static local variables and global variables are updated and its visibility is there throughout the program if it is global. If it is local, then its visibility is there within the function itself. So in this example, we have learned how to use the static local and global variables. The last type of storage class is called extern storage class. Extern stands for external storage class. That means this particular storage class is used when we have global variables or your functions which are shared between two or more files. Suppose you have declared one variable to be of external type and you want to use the same variable or function in multiple files or across multiple files, then we have to go for external storage type. The keyword extern is used to declare a global variable or a external type of variable or function in another file, so that you can provide reference to the variable or function where it is originally defined. So it is called inter-function communication or inter-file communication can take place if a variable is declared to be of your external type. Okay, the variables defined using extern keyword are called global variables, and these variables are accessible throughout the program. For example, how to declare extern void display. So here display is a method. This method or function, if it is external type, then you can use this function in other files also. So let us see one example how to make use of extern variables or functions. Now, in the first program, let us see there is a variable called I, which is declared to be external. That means it is global. So whenever it is global, then throughout the program you can make use of I in any function, or across the file also you can make use of the external variable I. So you can see here the value of the external integer I is nothing but initialized. You have not initialized any value, so the default initial value will be 0. Okay. In the second example, what you have done? We have taken the value of I, we have initialized with 48. So the 48 value will be reflected in the first file. So the value of I will get it as 48. Okay. So this way, in one file we have declared a variable to be external. In the other file, we have given the initial value for I to be 48. So that is reflected in the first file again. So the value of the external integer is 48. Whenever you will print it, you will get it. But the default initial value, if you do not assign any value, then it is 0. So let us come to the summary of the storage classes. So a storage class in C is used to represent additional information about a variable. So what are the additional information? The additional informations are what is the scope of the variable, what is the lifetime of the variable, what is the default initial value, and where the variable gets stored. This extra information we will get it from storage class type. So storage class represents the scope and lifetime of the variable too. And it also tells who can access the variable and from where it is accessible. That means it is within the function or outside the function or within the program, we can understand from the storage class type. Then there are 4 types of storage classes in C language: automatic, external, register and static. These are the 4 types of storage classes. And a storage class in C is used to define the variables, functions and other parameters. So these are the different things you can define using storage class concept. And automatic, whenever it is used, then it is for local variables which are defined within a block or function. Whenever you are using register storage class, it is used to declare the register variables which are normally stored in CPU registers rather than your main memory. Then static storage class is used for both global and local variables. Then the local variables can be used and it will retain its value throughout the function calls, and if it is global, then it can be retained throughout the program. Then the last type of storage class is called external storage class, which is used for data sharing between different C files. So you can declare some functions or for certain parameters or certain variables which you can share across the different C files. So these are the usages of different storage classes in C language. Thank you so much. So in this video, we have learned about the storage classes and its benefits in C language. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.